And welcome to Technology Tap. I'm Professor J. Rod. In this episode, Securing Windows, the Hidden Architecture of Trust. Let's tap in. Welcome back to Technology Tap, the podcast where we break down technology, cybersecurity, and IT careers in a way that actually makes sense. I'm your host, Professor J. Rod, and I am Professor of Cybersecurity, and I love helping my students pass the A+, Network Plus, and Security Plus series of exams. If you want to follow me, I'm on Instagram at Professor J. Rod, at TikTok at Professor J. Rod, on the Facebook at Technology Tap Podcast. And if you want to reach out to me, you can email me at professorjrod@gmail.com. I also have a website, professorjrod.com, and I'm currently selling my book, Scam Proof for Seniors, where if you have a family member who, doesn't really understand scamming or, is always getting scammed or potentially getting scammed, you can buy this book for them. It will help them avoid the pitfalls of being scammed. And it'll make a great Mother's Day, Father's Day gift for those of you who like to shop early. All right, so if you're studying for the CompTIA A+, thinking about entering the IT field, or just curious how technology around you really works, this is the show where we translate complicated systems into real-world understanding. And today we're diving into something that almost every IT technician touches daily: Windows security. More specifically, how Windows systems are secure, how users authenticate, how permissions work, how organizations control access, and why a simple folder share can accidentally expose an entire company. This episode is inspired by the training module of Securing Windows System, which is part of the CompTIA Core 2 exam objectives. But we're not just going to memorize concepts, we're going to understand the architecture of trust inside Windows. But once you understand that, everything else makes sense. So grab your coffee, open your notebook, and let's tap into technology. Most people think security means antivirus, passwords, and firewalls, but those are only the surface. Inside every Windows machine is an entire security architecture designed to answer one fundamental question: who are you and what are you allowed to do? Every file, every login, every network share, every application, Windows constantly asks those two questions. In cybersecurity, we often begin with the framework called the CIA triad, not the intelligence agency, but three foundational security goals: confidentiality, integrity, and availability. These three principles guide nearly every security system ever designed, and they apply directly to the Windows environment. Let's break them down. Confidentiality means only the right people can access information. Imagine a hospital system. Patient records must remain private. Only authorized doctors, nurses, and staff can access them. If anybody could open those files, you would have a massive data breach. Windows enforces confidentiality using permissions, authentications, encryption, and access control. Integrity. Integrity means data cannot be altered improperly. Imagine financial data inside a bank database. If someone modified numbers inside that database without authorization, that would cause millions of dollars in losses. Windows protects integrity through hashing, digital signatures, access permission, and audit logging. Availability. Availability ensures system remains usable. A perfectly secure system that nobody can access is useless. Availability protects systems from hardware failures, cybersecurity attacks, misconfigurations. Technology like redundancy, backups, and failover systems support availability. If you're studying for the CompTIA A Plus exam, memorize this, but also understand it conceptually. Because every security tool you'll learn later, encryption, authentication, permission, access control, all exist to support confidentiality, integrity, and availability. Now let's move deeper. At the center of Windows security is something called Identity and Access Management, or IAM. IAM answers 4 questions: identification, authentication, authorization, and access control. Identification means declaring who you are, typing in a username, selecting a login profile, entering an email. You're saying, this is me. But Windows doesn't trust you yet. Authentication verifies identity, proof, something that you know, something that you have, something that you are. Example, passwords, smart cards, fingerprints. If the authentication succeeds, Windows moves on to the next stage, which is authorization. Authorization determines what you are allowed to do. Example, 2 people logging into the same computer, one is the administrator, one is the standard user. They authenticate successfully, but their authorization levels are completely different. Access control. Access control enforces the decision. If you try to open a restricted file, Windows checks user permissions, group policies, security policies, then allows or denies access. Logical security controls. These systems are called logical security controls. They exist entirely in software. They protect the system by preventing or minimizing risk. Examples include firewalls, access control lists, encryption, authentication systems. They differ from physical controls like locks, security cameras, key cards. They both matter, but IT technicians mostly manage logical security controls. Access control list is one of the most important mechanisms in the Windows security. Every file, every folder, every resource has a list attached to it. The list says who can read it, who can write it, who can execute it, who can modify. Example, imagine a shared folder called payroll. Inside a company network, the ACL might say, accounting group has full access. Managers only have read-only access. Everybody else, denied. Windows checks that list every time somebody opens the folder. Implicit deny. Here's a concept many beginners miss. Windows follows something called implicit deny, meaning if access is not explicitly allowed, it is automatically denied. This is one of the most powerful security principles in computing. The principle of least privilege, another foundational rule. Users should only have the permission necessary to perform their jobs, nothing more. Why? Because most security breaches happen when accounts have too many privileges. Real-world example. Imagine an employee in marketing, but their account has local administrator privileges, database access, and server permissions. If that account gets compromised, the attacker gains enormous power. These privileges reduces damage. Let's introduce you to 3 words you will hear constantly in cybersecurity: vulnerability, threat, and risk. Vulnerability is a weakness. For example, in outdated software, weak passwords, or misconfigured permissions. Threat is something capable of exploiting the vulnerability. Examples, hackers, malware, insiders. Risk is the potential damage when a threat exploits a vulnerability. Security teams constantly evaluate risk. They perform assessments to identify vulnerabilities and threats. Encryption and hashing. Now we move into cryptology. 2 concepts that confuse many students is hashing and encryption. They're not the same. Hashing is one way. You take the data, run it through a hashing algorithm. It produces a unique fixed length output. The original, for example, you have a password and you run it through the hashing algorithm, it gives you a value. The original password cannot be easily reconstructed. Windows store password hashes instead of actual passwords. Encryption is 2-way. Data is transformed into ciphertext, but it can be decrypted using a key. Encryption protects confidentiality. 2 encryption models exist. One is called symmetric encryption, where one key encrypts and decrypts data. This is fast, efficient, and used for large data transfers. And then you have asymmetric encryption, which uses 2 keys, a public key and a private key. These keys are mathematically linked. Asymmetric encryption is slower but enables secure key exchange, digital signature, and secure internet transactions. Digital signature verifies authenticity. It confirms two things: the sender is legit and the message has not been altered. Digital signatures are essential for software downloads, online banking, and secure communications. Before encryption communication begins, two systems must securely exchange keys. The process is called the key exchange. Protocol like TLS handles this automatically. So, if you ever logged into your bank, Amazon, your email, encryption and digital signatures are working behind the scenes. You don't see them, but they protect every transaction. So far, we explored the foundation of Windows security, the CIA triad, the IAM, local security concerns, etc. But now we moved into something more practical: how Windows manages users and accounts, because every system ultimately depends on who logs in and what do they do. And that's when things get interesting. We talked about the CIA, IAM, and hashing, right? But now we're going to talk about the human side of security, because most breaches don't happen because encryption fails. They happen because of people and accounts. Someone logs in, someone clicks a link, someone has permissions that they should have known better, right? And suddenly, attack is made inside your network. This is why understanding Windows account and authentication system is absolutely critical. Every Windows system is built around identities: users, administrators, services, applications. All of these are identities. And every identity has permission, group membership, security policies. Windows is constantly checking these identities before allowing any action. So let's start with the basic. Windows has two major accounts: local accounts and Microsoft accounts. These accounts behave very differently. A local account exists only on one computer. The username and password are stored inside that specific machine. So if you create a local account called John on your laptop, that account only exists on that laptop. It doesn't exist anywhere else. This type of account is common for home users, standalone computers, small office systems. Local accounts are simple, but they don't scale well. A Microsoft account is a cloud-based. Instead of authenticating against the local computer, the local process authenticates against Microsoft services online. Examples include Outlook account, Hotmail accounts, and Office 365 identities. When you log into Windows using a Microsoft account, the system synchronizes settings across devices. Your themes, your passwords, your preferences, your applications can follow you between computers. Microsoft accounts offer convenience, but local accounts offer control. In enterprise environments, most organizations don't use either. They use something much more powerful: Active Directory accounts. We'll get to that soon. Imagine a company with 500 employees, and you need to give them permission for folders, printers, applications, and servers. Would you configure permission individually for every user? That would be chaos. Instead, Windows uses security groups. Instead of assigning permissions to users, you assign permissions to groups. Then you place users inside those groups. For example, accounting group, IT administrators, HR staff, sales team. Each group receives different permissions. Everyone inside of that group inherits them. Windows comes with several built-in groups. These include administrators, users, guests, power users. Each group has predefined permissions. For example, administrators can install software and modify system settings. Standard users can change personal settings but cannot modify core system components. The guest account exists mostly for legacy support and is usually disabled. Don't use the guest account. Groups allow administrators to enforce least privilege more efficiently. Instead of giving everyone administrative access, you can only give the IT team elevated privileges. Everyone else operates with restricted permission. This dramatically reduces the attack surface. Now let's talk about something many IT technicians use regularly: the command line. Windows includes powerful command line tools for managing accounts. One of the most important is NetUser. This command allows administrators to create users, modify accounts, reset passwords, and verify account information. For example, to create a user, you can type net space user space, and then to create the username, write student1 space password 123 space /add. To list users, type in NetUser. To force password change at login, you type in net space user space student1 space the multiplication symbol /logon password chg:yes. Command line tools are fast, they're scriptable, and extremely useful for system administration. Now let's talk about something everyone who uses Windows have seen. The little pop-up window, the one that has ask. Do you want to allow this app to make changes to your device? This is called the user account control. UAC is one of the most important security features in modern Windows. In the early version of Windows, many users operated as administrators all the time. This meant malware could easily modify system files, install software, alter registry settings, basically take full control of the machine. UAC changed that model. Even if you logged in as an administrator, Windows runs most programs with standard user privileges. When a program attempts a privileged operation, Windows pauses and displays a UAC prompt. This forces the user to approve the action. It creates a checkpoint in the security process. Interestingly, UAC also has a psychological effect. It makes users stop and think, did I intend to install this software? Should this application really modify my system? Security isn't just technical, it's behavioral. Now let's move on to the enterprise security. Organizations must carefully control accounts with elevated privileges. These include system administrators, database administrators, domain administrators. These accounts do enormous damage if compromised. PAM. PAM systems operate and control privileged accounts, and PAM stands for Privileged Access Management. They can record administrative actions, require approval for certain tasks, and limit access windows. PAM reduces the risk of misuse or insider threats. A relative concept is called just-in-time access. Instead of giving somebody permanent administrative privileges, they can receive temporary access only when needed. For example, an IT technician needs administrative rights to install software. Instead of always giving him admin rights, they request access. The system grants it for 30 minutes, then automatically removes it. This dramatically reduces attack surface. These ideas connect to a modern security model called Zero Trust. Zero Trust assumes no device is automatically trusted, no user is automatically trusted, and every access requested must be verified, even if the user is inside the network. This model is increasingly common in modern organizations. Now let's talk about the ways Windows verifies identity. Authentication methods are evolving rapidly. Traditionally, authentication uses one factor, usually a password. This is increasingly considered weak. Password can be guessed, stolen, phished, or leaked. Modern systems use multi-factor authentications. Authentication factors fall into different categories. Something that you know. Password, PIN, security questions. Something that you have. Smartphones, hardware tokens, security key. And something that you are. Fingerprints, face recognition, voice patterns. Or somewhere where you are. Location-based authentication or your login attempt must come from a specific network. Something that you do. Behavioral biometrics, typing speed, mouse movements, and user behavior pattern. Another authentication method uses one-time passwords. These codes expire quickly, usually within 30 or 60 seconds. Examples include the authenticator apps, SMS codes, hardware token. These systems generate time-based passwords that constantly change. Authentication apps like Microsoft Authenticator or Google Authenticator generate time-based codes. These apps implement algorithms like TOTP, time-based one-time password, or HOTP, hash-based one-time passwords. They dramatically improve login security, and I love them. I think they're one-time passwords is the way to go, in my opinion. Another authentication technique is called challenge response. Instead of sending a password directly, the system sends a challenge. The user device computes the correct response using cryptographic algorithms. This prevents password from being transmitted across networks. Some organizations use hardware tokens. These physical devices generate authentication codes. Example includes USB security keys, smart cards, token generators. Hardware tokens are extremely secure but can be costly to deploy. In the real world, organizations combined multiple authentication methods. A typical enterprise login might require a password, authentication app code, or biometric verification. Security is layered. If you want to succeed in IT security, remember this principle. Security is never one tool. It is always a stack of defenses. Authentication, permission, monitoring, encryption, policy. Each layer compensates for weakness in others. So far we explored the human side of Windows security, right? Users, groups, permissions, authentication table. But we now move to something every IT eventually works with. That is configuring Windows security itself. Things like Windows Hello, Active Directory, group policy, and domain authentication. This is where Windows becomes not just being a personal operating system, but an enterprise security platform. And that's where our journey continues on the next episode. Right? I think we should put a pin on this here, because it's a lot of stuff to absorb. So we'll make this a two-parter, right? So this will be the end of Act 1, and maybe I'll do like I do, because I didn't do an episode. I skipped a week because I went to the Women in Cybersecurity Conference, and I said I was going to do one there, but the internet was crappy. I couldn't do anything. It was going to be difficult for me, and I didn't have my headset. I didn't bring my headset. It was going to be difficult for me to do or my microphone. It's going to be difficult for me to do a podcast from there, though it actually would have probably been better because it's super, super quiet, but it would have not been a good thing. But anyway, yeah, we'll stop here. I'll try to see if I'll do like a 2 for 2 this week, since I didn't do one last week, and we'll get 2 episodes out. I just want to get one for the makeup of last week, and it's too long. I don't want to be, I think this might be like 40, 45, 50 minutes. I don't really want anybody listening to an hour of this. Usually half an hour. I think this is going to be like 20, 22, 23 minutes. It'll be good enough. I think that's good enough for us here today. So, again, I got my scam book, Scam Proof for Seniors out there. If you have a grandparent or a parent who's getting scammed or potentially getting scammed, or people calling them and they don't know what to do, or if you have stopped them from being scammed, this is the book for you. You can buy it on Amazon. You can buy it on my website, professorjrod.com. I think you got to look for /shop or /books. It's in there. You go to the website, you'll see it. And yeah, buy it, and hopefully it will bring some relief to you and to your family. All right, that's going to be all for me today. All right, this is Professor J. Rod saying, remember, keep tapping into technology. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. And you can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.